Earth is being pummeled by invisible forces from space. Our planet's magnetic shield is flickering under assault. Deep beneath the ocean floors, massive slabs of rock are grinding against each other, building pressure, and hanging above us, the moon is moving into position for something that happens only once a month. This isn't science fiction. This is happening right now. October started with a bang, and I mean that literally. At the stroke of midnight between September and October, a massive wall of charged particles from the sun crashed into Earth's magnetic field. For 72 hours straight, 3 full days, our planet was hammered by what scientists call a G3 geomagnetic storm. Think of it like this. Earth has an invisible shield around it, a bubble of magnetic energy that protects us from the sun's fury. For 3 days, that shield was being beaten like a drum. The impact sent shockwaves rippling through the shell of plasma surrounding our planet, thousands of miles up in space where satellites orbit. But here's the thing, that storm didn't just pass by and disappear. The effects are still here, they're still unfolding, right now, today, this very moment, and it's about to get more intense. 3 more waves of solar plasma are screaming toward us through the void of space. They're expected to hit between October 7th and 9th. Not just one impact, 3 separate blasts. The sun has been busy. Over the last day and a half, it's thrown a temper tantrum. First, a massive explosion erupted from its surface, boom. Then a gigantic rope of plasma, hundreds of thousands of miles long, snapped and blasted into space. Finally, another section of the sun became unstable and launched more material our way. It's like watching a volcano go off. Except this volcano is 93 million miles away and 1 million times bigger than Earth. Scientists tracking these plasma clouds have built models showing their path, and all 3 are aimed directly at us. We're standing right in the firing line. The 3rd wave, that's the big one. That's the punch that could really shake things up. Now, add another player to this cosmic game, the moon. Between October 6th and 7th, we get a full moon. You might think, so what? We get full moons every month. And you'd be right, but timing is everything. When the moon is full, it's not just bright and pretty in the sky. Something else is happening that most people never think about. The moon moves directly into Earth's magnetic field. It swims through that invisible ocean of charged particles surrounding our planet. And the moon isn't just some dead rock floating by. Its sunlit side carries a powerful positive charge. Its dark side carries a negative charge. This creates an enormous electric field. Imagine a massive electrically charged object, roughly a quarter the size of Earth, plowing through our planet's electromagnetic environment. Scientists have noticed something interesting. Geomagnetic activity tends to tick upward during full moons. It's subtle, like adding one more ingredient to a recipe. But when you're already dealing with solar storms, that extra ingredient matters. So let's count what's coming. 3 waves of solar plasma, a full moon moving through our magnetic field, and radiation belts that are already supercharged from the last storm. Oh, and there's more. While all this is brewing in space, something else is happening. The ground is moving. Right after that 72-hour solar storm began, earthquakes started firing off. Not little tremors, big ones. Magnitude 6.9 in the Philippines, the biggest quake of the past week. Magnitude 6.0 near Bali, Indonesia. Magnitude 6.1 off the coast of Kamchatka Peninsula in Russia. And just recently, a magnitude 6.0 off the coast of Japan. That last one should make people pay attention. Know where it hit? Roughly the same spot where a magnitude 9.1 earthquake destroyed the Tohoku region back in 2011. The one that created the massive tsunami. The one that caused the Fukushima nuclear disaster. Japan hasn't seen many big earthquakes this year. That's actually made people nervous, because the ground doesn't forget. Pressure keeps building whether earthquakes release it or not. The longer the silence, the bigger the eventual roar. But the real story is happening in Kamchatka. This place has become the most seismically active spot on Earth in 2025. Back in August, a monster hit, magnitude 8.8, a megaquake, one of the most powerful earthquakes in modern history, the kind that makes the entire planet ring like a bell. And since then, It just hasn't stopped. The aftershocks keep coming. And we're not talking about tiny tremors, we're talking magnitude 5s, multiple magnitude 4s. Week after week, the latest was that magnitude 6.1 just yesterday. Normal aftershock sequences fade away. They decline in frequency and strength, but not Kamchatka. This region keeps rumbling like an angry beast that won't settle down. Multiple volcanoes, they're erupting too. They've been blowing since August. Ash, lava, the whole package. Something is happening beneath that part of Russia. The question is whether it's finished or just getting started. Here's a detail that should make you think. Back in 1952, Kamchatka produced a magnitude 9.0 earthquake. The recent magnitude 8.8 was enormous, but here's the math that matters. It takes 2 magnitude 8.8 earthquakes to equal the energy of 1 magnitude 9.0 if there's still stress to release in that region. If it needs to reach that 1952 level, then Kamchatka might keep shaking for months, maybe years, and there's always the possibility of another megaquake. Back to that magnitude 6.9 in the Philippines. There's something odd about it. When you get a big earthquake, you expect aftershocks. The largest aftershock is usually about 1 magnitude smaller than the main event. So for a 6.9, scientists would expect to see a magnitude 6 aftershock within a few days. It hasn't happened yet. The smaller aftershocks are there, magnitude 5s and below. But that big aftershock, missing. This could mean nothing. Maybe it's just delayed. Give it another week and it'll show up. Or it could mean something else. In about 2 to 5% of cases, what looks like a main shock turns out to be a foreshock, a warm-up act for something bigger. Nobody's saying that's what's happening, but the absence of that expected aftershock is unusual enough to notice. Let's go back to space for a moment. Because something important happened during that 72-hour storm, Earth has radiation belts, 2 giant donuts of charged particles trapped by our magnetic field. The outer belt is mostly electrons. The inner belt is mostly protons. When that G3 storm hit, those belts dumped their contents. All those electrons came flooding down into the atmosphere. That's what created the spectacular auroras people saw across Canada and Alaska. The sky lit up green and red and purple. But now, days later, the belts have recharged. And they're not just back to normal, they're supercharged. The measurements are showing electron levels 100 times higher than normal in some spots. These are numbers that don't happen every day. The radiation belts are loaded like springs under tension. What happens when the next solar storm hits? Those belts will dump again. And with this much energy stored up, the resulting geomagnetic activity could be stronger than the models predict. There's one more factor that makes this October particularly interesting. It's called the Russell-McFerrin effect. Basically, Earth's magnetic field becomes more vulnerable to solar wind during certain times of year. The geometry between our field and the incoming particles allows for better energy transfer. The same solar storm that would cause a G1 event in June might cause a G2 or G3 event in October. October and April are the 2 peak months for this effect, and we're right in the middle of October's window. So these 3 incoming waves of plasma, they might pack more punch than they would at other times of year. Add it all up, supercharged radiation belts, the Russell-McFerrin effect, a full moon in the magnetosphere, 3 incoming plasma waves, and a planet still recovering from a 72-hour bombardment. The stage is set for something interesting. Here's where things get controversial. Is there a connection between solar storms and earthquakes? Look at the timeline. A massive G3 storm hits at the end of September. Within days, boom, 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 boom. 4 significant earthquakes strike around the Pacific Ring of Fire. Coincidence? Maybe. Mainstream science says there's no proven link. The forces that cause earthquakes, tectonic plates grinding and slipping, work on completely different scales than electromagnetic phenomena in space. The physics just doesn't connect. But some researchers have explored possible mechanisms. Could electromagnetic changes influence fluids in Earth's crust? Could stress in the ionosphere somehow couple to stress in the ground? These ideas remain speculative. There's no solid evidence, but the coincidences keep piling up, and people keep noticing patterns. The honest answer, we don't know. What we do know is that both things are happening. Whether they're connected or just happening to occur at the same time, the fact remains, Earth is getting hit from above and shaking from below. The forecast for the next few days is clear. 3 waves of solar plasma will sweep past Earth between October 7th and 9th. Best guess? We're looking at G1 geomagnetic conditions at minimum, but G2 is likely. Brief bursts of G3 are possible. Here's why those predictions might be low. Everything is primed. The radiation belts are charged. The magnetosphere is still unsettled. The Russell-McFerrin effect is active. The full moon is moving through the field. It's like having a room full of fireworks and somebody just lit a match. For people who are sensitive to electromagnetic changes, the next week could be rough. Some people report headaches, fatigue, dizziness, or mood swings during strong geomagnetic storms. The science on this is still developing, but enough people experience it that it deserves attention. For Aurora watchers, this is prime time. Strong geomagnetic activity drives the northern lights to lower latitudes. People who never normally see auroras might get a chance. The challenge will be the full moon. Its bright light will wash out some of the fainter aurora colors, but skilled photographers might capture something unique, the combination of moonlight and auroras together. The plasma clouds are still racing toward Earth at millions of miles per hour. The moon is still waxing toward its full phase. The radiation belts remain charged, and somewhere beneath the Pacific Ocean, tectonic forces are building toward their next release. Will the solar storms be stronger than expected? Will more earthquakes shake the Pacific Ring of Fire? Will the full moon's passage through the magnetosphere amplify the geomagnetic activity? These questions will be answered soon, within days. Actually, maybe even hours. This is the reality of living in the 2020s. We have satellites watching the sun. We have magnetometers measuring Earth's magnetic field in real time. We have seismometers detecting every tremor. We can track plasma clouds traveling 93 million miles from sun to Earth. But despite all this technology, nature still surprises us. We can see the storms coming, but we can't always predict their exact effects. We can measure stress building along fault lines, but we can't say when it will snap. The plasma clouds are still racing toward Earth at millions of miles per hour. The moon is still waxing toward its full phase. The radiation belts remain charged, and somewhere beneath the Pacific Ocean, tectonic forces are building toward their next release. Will the solar storms be stronger than expected? Will more earthquakes shake the Pacific Ring of Fire? Will the full moon's passage through the magnetosphere amplify the geomagnetic activity? These questions will be answered soon, within days. Actually, maybe even hours. This is the reality of living in the 2020s. We have satellites watching the sun. We have magnetometers measuring Earth's magnetic field in real time. We have seismometers detecting every tremor. We can track plasma clouds traveling 93 million miles from sun to Earth. But despite all this technology, nature still surprises us. We can see the storms coming, but we can't always predict their exact effects. We can measure stress building along fault lines, but we can't say when it will snap.